It's me, Maria Sandoval, and today I will be talking to you about types of chemical bonding and a few other things. So, I've had a few problems actually going through presentation mode, so I'm just going to be clicking on the slides and pointing at them. I'm sorry. So first we're talking about ionic bonding, and this involves a transfer of electrons and is usually observed when a metal bonds to a nonmetal. And here's a little picture of it you can see. So Na is our metal and Cl is our nonmetal, and E minus is our little electron up there, and you can see that our electron transfer happens here, and our cation and our anion come together and form this ionic solid of our Cl minus and our Na plus. So that is one form of bonding called ionic bonding. Moving on, there's covalent bonding, which involves the sharing of electrons and is usually observed when a nonmetal bonds to a nonmetal. So here in our figure B, you can see the nonmetal Cl and our nonmetal Br are electron sharing, forming ClBr, and they are separate molecules, and you can see each of these has a Cl and has a Br, and they're kind of just going off. It looks like they might be a gas at this point. And that's our covalent bonding. Metallic bonding involves electron pooling and occurs when a metal bonds to another metal. So here you can see that Na and Na and Na and Na and Na are all there. And then you have a bunch of metal ion cores in a electron seat. And they're all just like pooling there. They're just collecting, and nothing. It's not really bonding to form a solid or a gas like the other one. So moving on, we are looking at the Lewis dot structure, and specifically Lewis electron dot symbols. So to draw the Lewis symbol for any main group element, you should note the A group number, which gives the number of valence electrons, which 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A are all shown up here. And then you need to place one dot at a time on each of the four sides of the element symbol. I like to go clockwise, so 1, 2, 3, 4, 5, 6, 7, 8 if you have 8, or 1, 2, 3, 4, 5, 6, 7, however. You keep adding dots and pairing them until they're all used up. So here we're looking at our periods on the left, and here appears our group A number. And then you'll see that lithium has just one, so it only has one dot. Beryllium has just one, so it just has just two, so it has the two dots. Boron has the 3, carbon has 4, nitrogen has 5, and oxygen has 6, fluorine has 7, neon has 8, which is a full shell. 8 is a full shell. So after that, I think you'd move on to another shell. So nitrogen is in group 5A, so therefore it has 5 valence electrons. It can actually be shown 4 different ways, as long as there is a set of 2 electrons on one side and there are 3 on all the opposite. And you can see the different ways that they showed it there. So moving on, we're talking about our Lewis symbols and bonding. So for a metal, the total number of dots in the Lewis symbol is the number of electrons the atom loses to form a cation. So metal is the total number of dots in the Lewis symbol, and that is the number of electrons that this metal has to lose to form a cation. So for a nonmetal, the number of unpaired dots equals the number of electrons that the atom gains to form an anion, or the number it shares to form covalent bonds. So it could be 2 different things. So the octet rule states that when atoms bond, they lose, gain, or share electrons to attain a filled outer level of 8 electrons, or 2 for H and Li. So the ionic bonding model is an ionic bond is formed when a metal transfers electrons to a nonmetal to form ions, which is attract which attract each other to give a solid compound. The total number of electrons lost by the metal atoms equals the number of electrons gained by the non-metal atoms. And just gonna double check that we're on track really quick. Okay, yes. So we're going to be talking about how earlier we went over the orbital structures, the orbital diagrams, the electron configurations. Well, this here is going to show us how all three of them are shown on paper. So there are three ways to depict electron transfer in the formation of Li and F minus. L plus and L minus. So in our electron configurations, you can see that our Li is 1s2, 2s1 plus F 1s2, 2p5. And you can see that here our 1 and our 5 are going to change. So it becomes L plus 1s2 plus F 1s2, 2s2, this changed to a 2, 2p6, this changed to a 6. In our orbital diagrams, you'll see that it's the ones with the arrows and the boxes. So 1s, 2s, 2p. In our 1s box, we have an up and a down arrow, and in our 2s, we have an up arrow. For F, we have full boxes all across for the main part, except for our last box does not have our down arrow. So that's 1s, 2s. The 2p is missing its down arrow. So that gives us Li with only one full 1s, and 2s and 2p are empty. F minus with a full set now. Now we have our down arrow. So we lost it from our 2s and gained it in our 2p. So for our Lewis dot electron dot symbols, we're showing that our Li is being given to the fluorine. And that fills our fluorine shell. Now we have 8. So it's F minus 8, L plus, and it no longer has its electron. Moving on, we're looking at a problem where they're asking us to show these different types of structures. So the problem is to use the partial orbital diagrams and Lewis symbols to depict the formation of Na plus and O2 minus ions from the atoms and determine the formula of the compound formed. Our plan is to draw the orbital diagrams and the Lewis symbols for Na and O atoms. To attain the filled outer levels, Na loses 1 electron and O gains 2. 2 Na atoms are needed for each O atom so that the number of electrons lost equals the number of electrons gained. So, for our solution, showing our Lewis dot structure down here, we have 2 Nas, and they must lose their electrons, and they're being given to this O, the oxygen. Now the oxygen has 1, 2, 3, 4, 5, 6 outer valence electrons, which gives us 2 Na plus and O a full shell now, 2 minus. Doing this, we're using our partial orbital diagram now. We have our Na, and we have 3s, 2 3s, and 2 3p. They're set up the same way for the most part. Now each of these is going to give an arrow to our oxygen to fill out a whole set, because our oxygen is missing 2 down arrows in the 2p. So in the end we have 2 Na plus O2 minus, which gives us 2s 2p with all full sets of up and down arrows, and our formula is Na2O. So thank you so much for listening to me drone on today, and I'm sorry if I kept clearing my voice. As I said in the previous video, I've been pretty sick and it's affecting my voice a lot. But other than that, I hope you had a good time, and I hope you learned a lot, because I learn a little bit more every time I do one of these videos. Have a great day, and happy Easter. Bye. Ooh, if only I could get the button.